Dear students, I am Dr. Ashok Kumar Saini, Associate Professor in Mathematics in BLJS College, Tosham. Today I will deliver lecture on real and complex analysis for the students of BA BSc 6th Sem 3rd year on the topic elementary functions and Mobius transformation. In this we define linear transformation, a transformation of the type W omega equal alpha z plus beta, where alpha and beta are complex constants, is known as a linear transformation. Okay. We see that this transformation is the resultant of magnification, rotation, and translation. By writing omega equal to psi plus beta, where psi equal to e की power eta lambda phi and phi equal to az, where alpha equal to a e की power eta lambda. Thus, to obtain the defined transformation, we first magnify the region in z plane by the factor alpha equal to absolute value for alpha. A क्या है? A equal to absolute value. Then we rotate the region so obtained through an angle lambda equal to argument of alpha, and finally we translate the region so obtained parallel to vector beta through a distance absolute value of beta. This is z plane. Figure is this: phi equal to az magnification, psi equal to e की power eta lambda phi plane. Then w equal to rotation psi plus beta, phi plane psi plane, z plane phi plane magnification rotation w equal to psi plus beta. Then ट्रांसलेशन सीधा क्या हो गया, ये w इक्वल टू अल्फा z प्लस बीटा. ओके. Mobius transformation or bilinear transformation. This came in MD 2017-13-6. Mobius, a transformation of the form w equal to az plus b equal to cz plus d is called a bilinear transformation, where a, b, c, d are complex constants. Such type of transformation was first studied by Mobius 1770 से 1868, and hence it is sometimes called Mobius transformation. From 1, this is equation number 1, w equal to az plus b plus cz plus d. W into cz plus d equal to az plus b, or cwz plus wd minus az minus b equal to 0. Evidently it is linear both in w and z. Evidently it is linear both in w and z, so it is called bilinear. कहता है evidently it is linear both in W and Z, W और Z में लीनियर है, सो इट इज़ कॉल्ड बाइलीनियर, इसलिए इसको बाइलीनियर कहते हैं। CWZ plus WD minus AZ minus B equal to 0. Evidently it is linear both in W and Z, so it is called bilinear. ये क्या लीनियर है both in W and Z, so it is called bilinear. Let W1 W2 be the corresponding points in Z1 and Z2 in 1. तो W1 equal to A Z1 by plus B divided with C Z1 plus D. W2 equal to A Z2 plus B divided with C Z2 plus D. तो W2 minus W1 equal to A Z2 plus B divided with C Z2 plus D minus A Z1 plus B divided with C Z1 plus D. तो C Z1 plus D, C Z2 plus D, C Z1 plus D, C Z2 plus D, AD minus BC, Z2 minus Z1. This is equal to 0 if AD minus BC equal to 0. Therefore W1 equal to W2 if AD minus BC equal to 0. This shows that either W is constant or meaningless. W या तो constant है या meaningless है. Mobius transformation. So, hence if AD minus BC is not equal to 0, then W has different values for different values of Z. Z की different value है तो इसकी भी different value होंगी. If AD minus BC is not equal to 0, it is called the determinant of the transformation. And if AD minus BC equal to 1, then 1 is called normalized transformation. तो 1 क्या कहलाता है? Normalized. अगर ये 1 है, AD minus BC is equal to 1, then 1 is called normalized transformation. Critical points. Let W equal to T bracket Z equal to AZ plus B divided by CZ plus D. AD minus BC not equal to 0. AD minus BC, let W equal to TZ. Critical point. AZ plus B by CZ plus D. AD minus BC not equal to 0. B any Mobius transformation which associates a unique point of the W plane to any point of Z plane except the point Z equal to minus D by C where C is not equal to 0. Again the transformation Z equal to T inverse W equal to minus WD plus B divided by CW minus A is called inverse transformation of W associates a unique point of Z plane to any point of W plane except the point W equal to A by C where C is not equal to 0. These exceptional points Z equal to D by C and W equal to A by C are mapped into the points W equal to infinity, Z equal to infinity points respectively. दोबारा देखो again the transformation Z equal to T inverse W is equal to minus WD plus B Z निकाले CW minus A is called inverse transformation of W associates a unique point of Z plane to any point of W plane. जो W plane के साथ associate unique point of Z plane एक्सेप्ट द पॉइंट W इक्वल टू ए बाई सी, इसको छोड़ के, W इक्वल टू ए बाई सी को छोड़ के, वेयर C इज़ नॉट इक्वल टू ज़ीरो, C ज़ीरो नहीं है। These exceptional points Z equal to minus D by C and W equal to A by C are mapped into the points W equal to infinity and Z equal to infinity points respectively। अब इसको डिफ्रेंशिएट करते हैं, डी डब्ल्यू बाई डी टी, डी डब्ल्यू बाई डी जेड, तो सी एक्स प्लस डी का होल स्क्वायर, सी एक्स प्लस डी एज इट इज़ इंटू ए माइनस ए जेड प्लस बी एज इट इज़ इंटू सी इज इक्वल टू ए डी, इसको खोल लो, माइनस बी सी बटे सी जेड प्लस डी का होल स्क्वायर, और डी डब्ल्यू बाई डी जेड इक्वल टू इन्फिनिटी इफ जेड इक्वल टू minus dy c, 0 if z equal to infinity। The points z equal to minus dy c, z equal to infinity are called critical points where the conformal property does not hold if the complex plane is closed by the addition of the point infinity, then the transformation is 1-to-1 correspondence between all the points of the closed z plane and closed w plane। दोबारा करते हैं, the points z equal to d by c, z equal to infinity are called critical points। हमने क्या डिफाइन करा ना, critical points, तो z equal to यहाँ से, और डी डब्ल्यू बाई डी जेड इक्वल टू इन्फिनिटी इफ जेड इक्वल टू डी वाई सी माइनस डी वाई सी, 0 इफ जेड इक्वल टू इन्फिनिटी। द पॉइंट्स जेड इक्वल टू माइनस डी वाई सी एंड जेड इक्वल टू इन्फिनिटी आर कॉल्ड क्रिटिकल पॉइंट्स, जहाँ इन्फिनिटी और 0 है, वेयर द कन्फर्मल प्रॉपर्टी डज नॉट होल्ड, जहाँ पे कन्फर्मल प्रॉपर्टी होल्ड नहीं करती। If the complex plane is closed by the addition, अगर complex plane is closed है by addition है of the point infinity, then the transformation is 1-to-1 correspondence between all points of the closed z plane and closed w plane, then the transformation is 1-to-1 correspondence between all the points of the closed z plane and closed w plane। Next is fixed points or invariant points, the points which coincide with their transformations, वो points जो उनकी ट्रांसफॉर्मेशन के साथ coincide कर जाएं are called fixed points of the transformation। For example, if w equal to az plus b बटे cz plus d provided ad minus bc is not equal to 0, ad minus bc is not equal to 0 be any Mobius transformation, then fixed point for this transformation are given by w equal to z, thus z equal to az plus b बटे cz plus d। ये आप सॉल्व करो, सी जेड स्क्वायर प्लस डी जेड माइनस ए जेड माइनस बी इक्वल टू 0, तो सी जेड स्क्वायर प्लस जेड डी माइनस ए माइनस बी इक्वल टू 0, तो जेड निकालो ए माइनस डी प्लस माइनस अंडर द रूट डी माइनस ए का होल स्क्वायर प्लस 4 ए बी सी बटे 2c, देयर और जेड इक्वल टू ए माइनस डी प्लस माइनस अंडर रूट डी बटे 2c, वेर डी इक्वल टू ए डी ए माइनस डी का होल स्क्वायर प्लस 4bc, जहाँ पे डी क्या है, इक्वल टू ए माइनस डी का होल स्क्वायर प्लस 4bc। केस 1, इफ सी इक्वल टू 0 डी नॉट इक्वल टू 0, देन डब्ल्यू इक्वल टू ए जेड प्लस बी बटे डी इज इक्वल टू ए बटे डी इंटू जेड प्लस बी बटे डी, देन डब्ल्यू इक्वल टू ए जेड प्लस बी बटे डी इक्वल टू ए बाई डी जेड प्लस बी बटे डी। The fixed points are given by z equal to w equal to a by d z plus b by d, that is z equal to b बटे d minus a Now if a minus d not equal to 0, then by second we have one fixed point z equal to infinity and 3 gives another fixed point. Now if a minus d not equal to 0, then by second we have one fixed point z equal to infinity and 3 gives another fixed point. Now if a minus d not equal to 0, then by second we have one fixed point z equal to infinity and third gives another fixed point z equal to b minus d minus a minus d अगर 0 नहीं है, then from second discriminant, then we have one fixed point z equal to infinity. अगर 0 नहीं है, minus d is not equal to 0, and by second we have one fixed z equal to infinity and 3 gives another fixed point z equal to b over d minus a, which is finite. Again if a minus d अगर 0 है, then the transformation has one fixed point infinity. Thus we have the following results. If c not equal to 0, d not equal to 0, then the transformation has two finite fixed points. If c not equal to 0, d equal to 0, then the transformation has one finite fixed point. If c equal to 0, a minus d equal to 0, then transformation has only one fixed point at infinity. If c equal to 0, a minus d not equal to 0, then the transformation has two fixed points, one at one finite and the other at infinity. Theorems हैं कुछ. Show that generally these are two values of x as fixed points for which w equal to z, but there is only one if a minus d whole square plus 4bc equal to 0. Second, prove that if there are two distinct fixed points q and r, the transformation may be of the form w minus q by w minus r equal to k time z minus q by z minus r. Show that if there is only one fixed point, say q, then the transformation may be of the form 1 divided by w minus q equal 1 divided by z minus q plus k. This form is called normal form. Fourth, show that if there is only one finite fixed point p and the other fixed point is infinity, then the transformation may be of the form w minus p equal to k time z minus p. So the proof of this theorem we will do in the next lecture because we have limited recording. And you can view these online lectures from college website www.bljscollege.com, YouTube channel, college YouTube channel. Okay. So w equal to az plus b, proof 1, cz plus d such that ad minus bc not equal to 0 be any Mobius transformation for fixed point w equal to z equal to az plus b divided by cz plus d gives cz square minus a minus d z minus b equal to 0. z यहाँ से a minus d क्वाड्रेटिक है. ओके, थैंक यू.